Hey there, we're going to start talking about our last unit on stats, and we're going to begin talking about some of the more basic things like the measures of center and a way to display data called the Box-and-Whisker plot. It is a bit windy today, so if you can hear any of that, that's what that is. So at first, our table with all of our definitions, I'm going to leave this open to the key to do for us. So if you'd like to visit the key and fill in that table, that would be great. I just want to save a little time here. So we know frequency tables, they show how often a certain category happens. So when we have a table like this, and we want to know mean, median, mode, it might be a good idea to just go ahead and list in a comma-separated list rather than a table, so that we can really see the list of numbers, and finding the middle will be a lot easier. So the way you do that is you find out like what is tallied. So the tally goes here with students. So every tally gets a number. So there's going to be 2 tallies for 0, 2 tallies for 1, 4 sets of 2s, 5 3s like this, and 4 2s. It can be easy maybe to flip those in some cases, but it is the students count of a certain job offer. We're trying to find job offer amounts per student, so that's what we have to like repeat and list. Okay, if you ever have questions on that, you can always ask. So the mean, remember the mean is the average. So we add them all up and we divide by the total, which in this case was 15 if you count up all of those numbers. If you add all 15 of those numbers, you get 33. So the mean is 2.2. Median is achieved by finding the middle number in the set. So I'm going to cross off these a set at a time, a pair at a time. So I'll count 1 2 1 2 1 2 1 2 1 2 1 2 1 2. So I completed 7 pairs, and I do have a number left in the middle, so that's my median. Okay. The mode is normally the easiest to spot. It's just the number that shows up the most, which is 3. And we can see that in our table as well, because that was the most popular category. Okay, so an outlier, you may have heard the word before, is a value that is substantially different. Okay, so if you have a bunch of like test scores for students, and you're getting like 80s and 90s, but then you had a student get a 10%, that's an outlier. Okay, so it can be outlier in the negative direction, or it could be a really inflated score. Say you miscalculated a test and they got a 220%, right? That would be an outlier too. So they're normally due to miscalculations or just like weird occurrences. So in this data set, we just kind of see 54 stick out right away as the outlier. So this example says, hey, why don't you calculate mean, median, mode before and after taking out the outlier? Because we shouldn't really keep it in there if it truly is going to negatively affect our data and our conclusions. And there you have it again. People can change and show what they want to show, whatever they want, based on the numbers that they keep in, right? If they omit all the outliers, their data might look more concise. But if they include them, it shows that variability. Okay, so these are all decisions that people make to either lie with stats or to justly kind of report what's going on. So a key thing that we're going to be doing is listing numbers in order. So I'm going to try and do that here because they were all shuffled to start with. So you can just carefully do this. Sometimes people like cross off the numbers that they've used so they know they've counted everything. I'm writing them like this so I know I'm making sure I'm accounting for everything, keeping those columns. So with the outlier, the mean is going to be, again, the sum. In this case, we have 10 numbers. So the sum of these was 228. So the mean ended up being this. Median. So this is an interesting case because if we do our little cross-off game, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Remember, median means middle. It looks like our middle is actually somewhere in between here. And that division line, that has 5 on the left, 5 on the right. So that truly does appear to be the median. So what we do when that happens is we actually average the two numbers together, 19 and 20. Okay. And the mode is still 18. Okay? Let's go ahead and erase these dashes because I want to reuse the list again. On the right here, it wants us to calculate without the outlier. So again, let's see if our mean calculation is any different. So it's the sum, add them all up, divide by 9 this time. I got around 19.3. Median, again, 9 numbers. That's actually a little bit better. 1, 2, 1, 2, 1, 2, 1, 2. We do have a median. That's actually a point in our data set this time. Okay. Mode is actually unchanged. Okay. So when I look at my work I've done here, the median is pretty close, but the biggest difference is the mean. Because if we include that 54, that's gonna really jack up that average, right? And that's very, very common with these outliers, is that the mean is the most affected. Okay. So the second part of what we're going to do today, so you'll have some homework to practice on doing that sort of stuff, and the rest of the time we're going to focus on how to do a box and whisker plot and what that looks like. So box and whisker, what it does is it divides the data, that list that we made, into 4 parts, and they call those quartiles. Quart meaning quarter, right? 25%. And we also use the min and max from our list. And so it really ends up being 5 values. The minimum, Q1, which is 25% through the list, the median, which is 50%, halfway, is that's Q2, another name for the median. And then if you're at Q3, you're at the 75th percentile, meaning that you are larger than 75% of the values in the list if you are located right there at Q3, which looks to be maybe at like 80, 83. Okay? So it looks like the median is around, 72. Okay? So let's take a look at these last few examples and learn how to make these box and whisker plots for ourselves. So we got 2 locations here making strawberries, and we see their daily harvests. So let's go ahead. Again, the data is in chronological order by day, but it's not in numerical order, and we need numerical order for finding the middle. So let me go ahead and put these in order for you. And then we are going to figure out all of our stuff. Except for the min and max, because that's pretty obvious. This is the min, and this is the max. I'm not going to rewrite it. However, we don't know Q1, median, and Q3. 7 days in a week. So 7 means that it's odd, which means that it does have a nice median. So that's going to be right here in the middle. So 80 is our median. So Q1 is 25 percentile, which means it's halfway in the first set. So it's like you cut it in half with the median, but then you cut the first part in half with Q1, so that you have a middle point from 0 to 50, so it's 25%. Okay. So you just pretend like this is a new list of 3 things, and if we found the median of that, it would be at 65 since it's in the middle. Okay. You can also have ties with this, and then in that case you take the average between the 2 numbers. We'll see that a little later, I think. But again, with this grouping, the top half, we see that we can find the middle there is 90. Okay, so making the plot is pretty basic. All you gotta do is just put the min and the max first, and then put your other 3 points in the proper location. So 80's in the middle, 90's in the middle of these, and 65 is a little closer over here. And then what you do is you just put 5 marks like that. The whisker part is these little ends, and they connect like that, and then the box connects like that. And that's a box and whisker plot. It shows the spread of the data, and it also shows if there's clusters of... Now, we don't have that much data. We only have 7 data points. So this graph is great, but it doesn't really truly reveal about the harvests. This was just 1 week. But it should reveal, say, when this whisker is shorter than this one, there's more data points piled in this. It's more dense, right? And then, of course, a really key point in looking at these is the median, which is that middle slash through that box, okay? Again, you could repeat the same thing here. So this is the sorted list for this. And go ahead and try and see if you can make the box and whisker before I do here in a couple seconds, okay? And we'll compare. So go ahead and pause the video and try to make the box plot with these. Find those 3 values, find min and max, and then graph it. Okay? This one's a little bit more flavorful, I would say. I just went ahead and just dove right into the 5 numbers. I know that this is the median in the middle, and I know just from before that those are Q1 and Q3, and I can find my min and max. So those are my 5 data points. So this one seems like a lot of the data is a little bit more clustered over here, because remember, half the data lives in the yellow circle, but half the data lives in this zone too. See how that zone's a lot bigger, so it's a lot more spread out. Okay. The two cities compared to each other, it's hard to do it when they're not on the same number line, but we can see that in Plant City, the median is a lot bigger, almost double, and the range is a lot bigger. So in Plant City, seems like you could get 100 one day and then get 200 the next day, right? So it's pretty variable. Whereas in San Jose, it's a little bit more tight, a little bit more predictable. Okay. So again, let's try and find out, we have another data set. Let's find the median Q1 and Q3 again. By the way, I don't think I've mentioned these things, range and interquartile range. Range is pretty simple. It's just the biggest minus the smallest. So for example, here the range is 100 minus 60, which is 40, and the range of the other one is 100, right? Interquartile range, IQR, that's the length of the box, right? So IQR would be, because this is a quartile, this is a quartile, the interquartile range is defined as the length between those two. So it'd be 90 minus 65, which is 25. Interquartile range is used to see the range of your middle of the run data points, right? Your middle 50%. Also, it's the same as the measurement for range. It's measuring the same thing. Range can be a little wonky if you have outliers, right? So say we did have a day where we got like 1,500 strawberries just for no reason. The range would get really wonky, but the interquartile range would still be kind of accurate. So it's not as affected by outliers, whereas the range is like really affected by those min and max. So just a lot of things to think about. So this time we have 8 data points. So it's a little awkward because the median would fall here, which means that it's at 19.4. And then we're left with a left side and a right side. So the top 50% and the bottom 50%. And it's 4 numbers again. So we don't have a number to circle. Instead, this is going to be Q1 and this is going to be Q3. So Q1 has to be the average. Okay, so 18.9. And then if we average those, the way I do averages is you can add them up and divide by 2. But I know they're a distance of 1 apart. So I'm going to cut that in half and do 0.5 and add that. So 20.1 would rest halfway between those two numbers. Again, I took the difference 1 and cut it in half and then added it to the first one. Anyhow, so let's put this on this graph together. We're going to put men right here. And we got this. We got the median, which is around here. And then 20.1 is around here. And we also have the min and max. So the max is a little further out. But that's the, you could also call it a box plot. That's the box plot for men. So there's a lot of things you could notice. For example, there was a woman who, the max here, who got a score, a length of the shot put, the distance was better than half, because this would be half the 50 percentile for men. It was above that, right? So we had a woman who was very competitive with the men's score. But overall, it seems like the men's range is a little smaller, and even the worst performing man in the study was still above the 75th percentile for women. Okay? So they're in the same ballpark, but men seem to throw a little further when studying this. Okay? Great. And of course, with more data points, with more qualifying distances over the years, we maybe could have an even better understanding to see if there were maybe some women who beat all the men's score one year, or other things. But we have a small snapshot, so that's all we can do. So real quick here, our data's in order. We're looking to plot with and without the outlier. So with and without, let's just go ahead and circle and identify what the median and IQ are and all that. So what is the outlier, by the way? It's this right here. 52 is substantially smaller than the other values. So what we're going to do is just kind of mark what's what. So there's 6 data values. So the median is right here, Q2. Let's put that word down there, Q2, and that would have to be 88, right? Because it'd be halfway. And then you have a bottom set and a top set. Bottom set, top set, they both have 3. So I know that this is my Q1 and this is my Q3. And then of course we have our min and max. So let's plot the width. So we got 52, we got 78, we got 88 is our next number, and then 95. Okay. Oh, did I miss a number? Yeah, 99. Okay. That's how you do it. All right, and let's take a look to see what happens when that outlier was taken out. For one, it's going to look a little different because this is now going to be Q2, our median. And the bottom and top set only have two numbers, right? So you can't circle one of them because then it wouldn't be even. You have to go in the middle. This is Q1 and this is Q2, so you have to average. So that would be 82 and 97. So min, Q1, Q2, Q3, oops. Okay, it's like right here, and then the max. Okay, so we can see what happens with these plots, right? When the outlier is taken out, right? It changes everything. It makes it look like a completely different data set, right? So notice that the IQR, the length of this box, is about the same, but the range is not. The range of the blue one with the outlier is like almost 50, right? But the range of the without is about 20. Okay, so it changes the picture substantially. So last thing I'll say is what they'll do sometimes is instead of putting a dash there, they'll actually put a dot and they'll go to the next largest point. So the second minimum, which would be 78. Yeah, which I guess would just look like this. You know, it would be really short there. It wouldn't even really be there. We have so few data points, that's kind of weird. But sometimes you can put a little dot to note the outlier so it doesn't, we don't want the whiskers being super long because that's kind of unclear. You know, does that, if I put the whisker here, does that mean that some of the data is here or here? Is it equally spread out? You know, we don't really know. So if there is a huge outlier, you'll often see that they'll put a point here indicating that outlier and then excluding it from the running for the minimum. Okay. Try out the homework. If you have questions, you know who to come to.